Hello third year, it's Mrs McInnes here. So in today's lesson we're going to be continuing our work with circle geometry, so using our Pythagoras theory to find the length of a side in a triangle that's contained within a circle. So just to recap what we need to be able to do, we obviously need to know our Pythagoras theory. We need to be able to identify a chord and a perpendicular bisector, and then obviously apply your Pythagoras theorem to finding a missing side within your triangle. So first of all, what I'd like to do is just a little recap with you of what those two new parts of a circle are called and where they are. So you've got your chord, which is the green line there, so that is a line that joins any 2 points across your circle. You then in red have your perpendicular bisector, so that is your line that crosses your chord at a 90-degree angle and cuts the chord into 2 equal parts, okay? And if you've got your chord and your perpendicular bisector, it will form a right angle triangle, which you can then use Pythagoras with in terms of finding a missing value. Alright, so the first example I'm going to do is just a very quick recap of the basics, okay? So here you've got your illustration where you can see that you've got your chord along the bottom, just across here, the 7 centimetres, that's your chord, and then running down the centre in green there you've got your perpendicular bisector. That is then forming your little right angle triangle. You can see it there, it's really easy to spot there, it's just that one there. And we're being asked to find the length of the side that's marked as D. So your working is just going to be straight into Pythagoras. Now because that side is a short side, it's going to be 9 squared minus 7 squared. So that's going to give us 81 minus 49, which leaves us with 32, and then we square root that value to get D, because up to that point that's D squared. So D is in the square root of 32, which is going to give you 5.7 centimetres. Okay, so just your basic Pythagoras, a very straightforward illustration there for you. Now, what I would like to do in terms of the rest of these examples is give you questions in a context. So these are going to be kind of similar to the ones in the booklet that I've chosen for you to do today. So here we have got a question that is set in the context of that this is supposed to be a drain pipe with some water in it. Okay, so first thing to do is let's read through the written section and look at anything important here. So the diagram shows a section of a cylindrical drain with a diameter of 1 metre. Okay, so if your diameter is 1 metre, that means your radius will be half of that, so 50 centimetres or 0.5 metres, depends what units we're going to use, okay? The next thing that's important to see there is the surface of the water in the drain AB is 70 centimetres. So you're told that A across to B, this length across here is 70 centimetres. So the first part of this question says write down the length of O to A. So it's asking you just to write down the length of that side there, O across to A. Now, we should be able to recognise that that is just your radius, which is why I said to just jot that down because it will be useful. So your radius, I'm going to write it in centimetres because the length of AB is in centimetres, so I'm going to use everything in centimetres. So O to A is 50 centimetres, that's your radius. For part B, we're asked to calculate the depth of the water in the pipe, which is marked as D, and it's actually asking for your answer in to the nearest centimetres. So we will work in centimetres here. So if we look back at our right angle triangle, okay, let's fill in what we know. So we know this length O to A is 50 centimetres. And we also know the bottom edge of that triangle because A to B is 70, so that would mean that this edge down here would be half of that, so 35. So the side that is missing is just this side here in green. That's the side of your triangle that's missing, okay? Now if we're trying to find D, which is just this measurement down here, those two things together are a radius, okay? So from O all the way down to the bottom, you can see there we've drawn it in yellow, those two things together is a radius. So if I work out the length of this green side of my triangle, all I would have to do is subtract that from my radius, and I would be left with the value of D, which is just this part down here. Okay, so we're going to go ahead and find that missing edge of that triangle. So what you might want to do is just draw it out separately from the picture. If you want to do that, that's fine. So 50, 35, and this is the side we're finding, so let's just call that x. So x squared, now that's a short side, so it's going to be 50 squared minus 35 squared. So that's going to give us 2,500 minus 1,225, and that leaves us with 1,275, and then we do our square root, which is going to leave us with a length of 35.7. I'm going for one decimal place here, centimetres. Now, the question didn't ask for this side, it asked for the depth. So for the depth, we're going to do our radius of 50, and we're going to subtract that 35.7. So that's going to leave us with 14.3. The question said to the nearest centimetre, so I'm going to round that to 14 centimetres. Alright, so this type of question you will see quite a lot in the questions in the worksheet. Okay, so I'm going to show you another couple of these. So the next one I've got is just similar context. This is supposed to be a mine shaft, and again there's water in there, so it's a sort of tunnel pipe type of shape with some water in there. So similar to the last one. Now again, we're going to go through and read the written section and just jot down anything that's important. So the diagram shows a section of a disused mine shaft whose diameter is 2 meters. So if your diameter is 2 meters, your radius is obviously half of that, so 1 meter. So that's always helpful just to note down. And then we have the surface of the water, AB, is 140. Okay, so that is your line, your chord across there at 140. So the first part of this says write down the length of OB. So this is very similar to the last question. This length here, O to B, that is a radius. It's the centre to the edge of your circle. And we wrote that down already as 1 metre. So 1 metre, or you could write 100 centimetres. Either would be fine. Now the next part says calculate the depth of the water in the pipe X. Give your answer to the nearest centimetre. So over here we have marked on here the length of X that we would like. Now I'm just going to move that across onto the diagram, and what that will do is it will make my triangle, so it'll make it a wee bit easier for you to see what we're being asked for. So again, thinking of our strategy, okay, from the centre down to the edge, so if I draw on that in yellow, that's a radius, we know that that's 1 metre. If we then work out this part of our triangle in green, we would just simply add that on to a radius, and that will give us the full height of that water. Okay, so we're going to be finding the green side of the triangle, so let's jot in what we've got. So our OB is at 1 metre. I'm going to write that in centimetres just because the length of the chord is in centimetres as well. So we've got 100 centimetres for O to B. If AB is 140, we're obviously cutting that in half, so that would make this side 70. Okay, your perpendicular bisector will cut your chord in half. And then we're left with the green side, so I'm just going to call that A. Okay. So again, if you want to draw that out separately, you can do. Just realised I've drawn that upside down. If you want to draw it out like this, you can. So we're finding this side, we've got 70 at the top, and we've got 100 for our hypotenuse. So for our missing side, A squared, it's a short side, so it's 100 squared minus 70 squared. So that's going to give us 10,000 minus 4,900. It's going to leave us with 5,100, and then we will square root. That gives us a value of 71.4 centimetres. So remembering to answer the question, the depth of the water in the pipe X. So X is our 71.4 plus a radius of 100. So we've obviously got 171.4. And the question said to the nearest centimetres, so 171 centimetres. Alright, so sometimes you'll find you are adding the side that you found to a radius to get your total height. Sometimes, like that previous example, you will be subtracting the side of the triangle from a radius to find a height. Okay, so there's two versions of that question.